Hello again. Today I'm going to finish teaching you what I started in the last tutorial about lightning and thunder. This tutorial today is about lightning, the actual lightning process, and getting a basic understanding of thunder, and some other interesting items. So, right where we left off. Here's where we left off. We uh, we finished talking about how the let's do an overview actually. The hail particulates um, and the hailstones and the ice particulate particles, they moved around, and the the ones going up um, bumped against the ones going down and caused a negative charge on the bottom of the cloud and a positive charge on the top of the cloud, and that caused a positive charge on the ground. And with the positive charge on the ground, that caused things on the ground like uh, houses or telephone poles or trees to become positively charged as well. And so that's where we left off. Now what we're going to talk about is um, right now. Um, so at the bottom of the cloud, um, a channel of negative charge called a stepped leader comes down from the bottom of the cloud towards the ground. It's actually invisible to the human eye, so you can't see it. And so I'm going to draw this out real quick. And this is negatively charged. And so also what happens is we have a something similar to the step leader. Um, it's a positive charged um, a positively charged channel comes from, in this case, the telephone pole, and it reaches out to the negative step leader with its own channel called a streamer. And this is positively charged. And when these two connect, it results in what we see as lightning. And now that's visible, so we can actually see it. And it follows the same path that the stepped leader follows, and then it follows the same path that the streamer follows. And if there's enough charge left over, then there will be more strokes following the same channel, or like the route, following the same route. That's how I like to think of it, which gives, like when you look in the sky and you see lightning, that's what gives it a flickering appearance when when more streams come through the same channel. So that can happen several times. Um, and actually, now I'm going to start talking about positive lightning. And how that works is you have your big, oops, there we go. You have your big cumulonimbus cloud. It's actually bigger than that. I'm just drawing a really small one. It's not that small. It's much larger than that. And we have the negative on bottom and the positive on top. And so what happens is it's very similar. It's the same process as the negative lightning, but the exact opposite. Eh. Oops, what happened? Error 32. Let's do this again really quickly. Positive on bottom, sorry, negative on bottom, positive on top. And what actually happens is, instead of the ground becoming positively charged because the ground is attracted to the negative, it's actually something weird happens, and it actually starts getting attracted to this positive charge up top. So the ground becomes negatively charged, and what happens is we have like before, we have our step leader, and we have our streamer coming from the ground, and this is positively charged in this case. And this is negatively charged. You get the idea. And so like before, we have our, it follows the same route or channel as these two. That's really bad, but anyway, it goes the same exact way. It's not floppy like this, it goes the exact same way, and it makes the connection, and it's lightning. But this is really rare. This doesn't happen very often, where it's the exact opposite as the negative lightning, but when it's positive, it's the exact opposite as the negative. And this is, it's very, very rare. It does not happen does not happen as nearly as often as the negative lightning. And so actually, it but it's a lot more powerful. It's very, like I said, although it's very rare, the positive lightning, um, it it's it's significantly more powerful than the negative lightning. All right, next, what we're going to talk about is we're going to talk about how thunder happens. And there's not much I can show you here. So we have lightning now. There's lightning. Here's our lightning. And what we have is what thunder is. Thunder is, it's actually an acoustic shock wave, and it's generated by the extreme heat from the lightning flash. Because lightning can be as hot as up to 30,000 degrees Celsius. And lightning is actually plasma. Um, that doesn't really have much to do with that, except but it's a cool fact. But the temperature can get all the way up to 30,000 degrees Celsius, and so it's very, very hot. And when that happens, like all gases, air molecules, when air molecules are heated, they expand, um, and the faster they heat up, the faster the rate of expansion is. Because thunder is just rapidly rapid ex the rapid expansion of air. So thunder is similar to like exploding fireworks, um, or like a sonic boom. So the thunder, the heat, it heats up the air, and so it makes them move faster and it makes them expand. And the expansion, the faster it happens, it just makes a boom, and that's the thunder, the sound. So yeah. Thank you guys for watching, um, and I will see you guys later.